Welcome to this video. So today I want us to work on a simple project regarding calculations. So you can see from the topic here, geodetic problems. So I want us to work on a few problems. I've already snipped them, so I just want us to take a look at it. So in this question, it's a traverse question. The traverse diagram on fig. Okay, so I'll show you the figure very soon. It's an abstract for a polygon traverse. This is the nature of the traverse. It moves from 1 to A to 1, 2, 3, 4 back to A, and then it starts at existing control point A and is oriented to existing control point B at these coordinates. So now I want us to work on this part. Okay, I want us to work on this part. So the problem right now is if you are giving controls, okay, if you are giving coordinates of 2 points, all right, let's say from this question you have coordinates of point A and point B. How do you calculate the bearing and distance between these two controls? Okay, if you are familiar with this kind of calculation, you realize that you need your bearing and distance, okay, in order to start computing for the bearings and distance for the other traverse lines. Okay, so now I want us to look at how we can be able to calculate the bearings and coordinates and distance from these two control points. Okay, so let's see. Let me just show you I'll show you the diagram. So the diagram is here. Okay, so this is the diagram. It moves from B to A, then 1, 2, 3, 4 back to A, and then so B and A are the control points. Okay, and now they want us to calculate the bearing between B and A so that this traverse and the bearing of the traverse legs can be computed. Okay, so let's start. First off, if you want to work on something like this, you need to consider how do you want to receive your inputs. Okay, so assuming someone is using your script, how do you want the person to give you inputs? Very soon we will work on how to receive input from Excel files, but until we've done that, I want us to continue using the console as our source of input. Okay, so we'll be using the input function to take our input from the user. All right, so we are first going to I want us to look at it. First we'll create a list. Okay, a list that will take our coordinates, and then we will also request the coordinates from the user. We'll take the coordinates and then do the computation. So let's work with the first part, how to take the coordinates. So I'll just put first step here. First step, our first step will be receiving coordinates. Receiving coordinate data, okay, from user. Okay, so how do we do that? Like I said, we'll be using the input function. So let's say x or eastings. So this is eastings and northings. So let's say easting 1 equals to, then float inputs. Remember, the coordinates could be in the form of floats. Okay, it's not always they are in decimal, so it could be in the form of floats. So I would say give the easting for the first coordinates. Okay, then we would give some space for this, or let's just say something like this. Okay, then we'll repeat the same thing because we will be taking the northings. Okay, so remember, let's look at the question again. This question has eastings and northings. Oops, sorry. This question has eastings and northings. So control point A has eastings in meters, and then it also has northings also in meters, the same as B. So we want to take this one from the user, then also we'll take this one from the user, this part, then we'll come and take for the second control its eastings, and then finally we'll take its northings. I hope you get the idea. All right, so someone asked me to zoom in a little. Yeah, okay, so I hope this works. All right, now we've been able to, so this one will be called nothings 1 or nothing 1, nothing 1. And then we will have, so I'm just going to repeat the same ones for 2, 2. Okay, so so this one will be nothings. I hope I'm not confusing you. Alright, I will explain at every step what we've just done. Okay, so what we've done right now is we've taken the listings from the user. We are asked, when this code runs, the user would input the listings. When this code runs, he will input the nothings for the first one. Then when this code runs, he will input the listings for the second one. When it runs again, he will put the listings, the nothings for the second one. I hope you get it. Now we need to put these codes, okay, into, we need to put these variables into a list or a container so that it can always hold our data for us until we need to work with it, then we can always take it. All right, so otherwise you can just leave it like that, but I prefer to work in an organized manner. So I would create a list up here. So I'll say point 1 or control 1, control 1, and control 2. Let me see. Let's put everything inside 1. Okay, let's put everything inside 1. So control 1 will have a list. Okay, we've not okay, like this. So control 2, then we would give the listings and nothings for control 1 into this one. So we'll say listing 1 comma listing 2, sorry, nothing 1. And in the same way we'll give listing 2 comma nothing 2 to this guy. What's this? Undefined name listing. Oh, sorry. This one is supposed to come below this guy. Okay, so that it can work. What's this? Listing 2. Listing 1. Oh, listing 2. The reason why the previous one was not working is because we are using a variable that is not yet defined. But if you bring this code down here, then listing 1 and listing 2 will be defined up there. Remember, it has to know what is up there before it can do what is down here. All right, so now let's try to run the code and then print out. At the end of the day, we want to print out our coordinates to see if it works. Okay, so print control 1. We should replace this control 1 with like this, so we don't have to type too much, like this. So print control 1, or we would say print control 1, then like this, and control 2, then like this, dot format control 1 comma control 2. All right, so let's run it and see. Just move this guy here. Actually, I think I should okay, it has come. Give the listings for the first one. Listing for the first one will be I think I wrote it here, 642.515. I think I wrote it here. Yeah, 642.515. And then nothings 48 483.980. And then for the second one, 548.005, and then 594.279. Okay, so it prints for us. This is what Eastern one control 1 is. It's giving us the values we've just inputted. Alright, so we are on track. Okay, so now let's see if we can sorry. So now let's see if we can. I'm just going to remove this one, or just comment it out. I don't think we'll need it. So now that we have our controls, okay, now if you want to do the calculations, I'll record another video, or I'll share with you a link to another video where you can see how the calculation is done manually, okay, with a book and a pen, or a marker and a board. But right now, if you want to understand how it works, you need to calculate your what's the name, difference in latitude, difference in northings and difference in eastings. What it means is that you do control 2 minus control 1, then you get your differences. Okay, so let's just do that now. So change the nothings. Change the nothings would be, I'll change the nothings to be control 2 minus control 1. Okay, so control 2 nothings is the second one, so minus control 1. Don't worry, I'll explain what is happening very soon. Okay, and then the same for the eastings. Change eastings. Control 2 0 minus control 1 also 0. Now what's happening here is, I'm saying that, the Python list starts to count from 0, right? So the first element is 0. If you look at this list, this is actually 0 and this is 1. Okay, so I'm saying that it should take the control 2 element, it's 1, so this guy 594 minus the 1 for this guy 483. That means that nothing 2 minus nothing 1. Okay, so it's following this format. Let me put this as, it's following this format. Change equals nothing 2 minus nothing 1. Okay, and easting 2 minus easting 1. That's the format we are using. That's just what is down here. Okay, all right. So now that you've been able to do this, now that you've been able to get the differences, okay, what you want to do is you want to consider which quadrant the coordinates fall in if you are plotting it. Okay, so if you take this one, for instance, this particular one, for instance, let's just print. Okay, so I'm just going to copy this one. So let's print. Oh, you know what? It's easier to do it all over again. Print changes northern and eastern. Okay, print changes northern and eastern like this. Then dot format, we just want to see the format. Then we have nothing 1, so we have change nothings. Change nothing and change eastings. All right, so the reason why I'm printing this one is because I just wanted us to see what values it will give us. Ideally, I'm very sure it will give us answers. Okay, and very soon I'm going to stop printing because it's going to be quite tedious printing and inputting the values. Okay, so the first one is 642.515, 483.980, 548.005 and 594.279. All right, so it gives us the changes. Changes in nothings is 110 and changes in these things is negative 94. Okay, so now the reason why I wanted you to say this is because to see as the answers, I wanted you to see these answers. Okay, you realize that one of them is positive and the other is negative. Now when you're plotting on the what's the name, when you're plotting on a graph, okay, and you are looking at the quadrants, so when you're plotting on the Cartesian plane, you realize that the negative answers or the negative changes are going to fall. Let me just get this map for you. Okay, so when you consider this one, I don't know if you, oh sorry, so when you consider this one, you realize that it's going to fall in this quadrant: negative eastings, positive northings. Okay, so negative eastings, positive northings. It's going to fall up here like this. All right, so now, sorry, it might be tilted, but I would show you manually how to do it. So for now, whatever angle you calculate, okay, is going to be with respect to the y-axis. That's our northings. Our eastings is the x-axis, our northings is the y-axis. So whatever angle we calculate is going to be with respect to the y-axis. So it's going to be something like this. Oh good, I have a picture I want to show you. Minimize this guy. Okay, so now that's what I'm talking about. When you look here, you'd realize that when you look at the Cartesian plane, this one is, if the change in northings, this is northings, okay, and this is eastings. So if the change in northings is positive and the change in eastings is positive, then it's going to fall in this quadrant. Now when the change in northings is negative but the change in eastings is positive, it's going to fall here. When the change in northings and change in eastings are both negative, it's going to fall here. I hope you are getting it. When the change in northings is positive but the change in eastings is negative, then you realize that it will fall in this quadrant. And this is currently where we are. Our change in northings was positive, but our change in eastings was negative, and so we are in this quadrant. And I'm telling you, if you want to solve it easily, okay, if you want to understand how to do it, I mean, there are a lot of ways people do it, but the one way I do, which does not confuse me, is I always tell myself that every angle I calculate is with respect to the y-axis. Okay, it's with respect to this y-axis. So if it fell here, then this is my angle. Okay, this small part, this is my angle, this side. And if I had calculated whatever, if my quadrant was here, then this small part would have been my angle. This small part would have been my angle, and this small part would have been my angle. Okay, so now that you've seen this quadrant and the effects of the signs, okay, you realize that whatever changes you get, it can either fall in a particular quadrant. Now, this is the formula we are going to use to do our calculation. Tan inverse of change in eastings over change in northings. Okay, so this is the angle I'm talking about. Whatever angle I calculate, I assume that it's with respect to the y-axis. Okay, so when we put this into the code, when we add this formula into the code, and then we calculate whatever angle, it's not a bearing, it's just an angle. Whatever angle we get, we will decide what to do with the angle for it to turn into a bearing. Now, like I said, it's just an angle, it's not a bearing. So this diagram is actually showing you what the bearing means. And like I said, we are in this current scenario. So if we got an angle here, okay, if we calculate and we get our angle, it's going to mean this angle. Let me zoom in a little. It's going to mean this angle. All right, now if you want the bearing from the northings, remember, if the bearing is from a reference line, okay, so if you want a bearing from the northings all the way to that line, then it means that you need to add this angle to this angle to this angle to that angle. Okay, all right, or since you have this angle, you just subtract this angle from 360 and you will have the rest of the angles. You get the logic. I hope you get it. So that's how it's done. So whatever angle I get, I subtract from 360 here. If it were here and I know that it's with respect to the y-axis, then it means I just need to add 180 to this angle to get my bearing. If it's here, my bearing is my angle, okay, automatically, because it's with respect to the y-axis. And if it is here, then it means that I need to subtract this angle from 180. Sometimes you get your angles as negative, so instead of doing minus, you just do plus. Let's see how it works. All right, so let's go back to our code. I'm just going to take this guy off. Okay, I think I should leave him. He is quite helpful. All right. Okay, so now let's come down here. I think my zoom is too much. Okay, so now let's do the calculations. We know that bearing equals tan inverse of change in eastings over change in northings. Okay, so now if you want to do mathematical calculations, like serious mathematical calculations, you can import this a library called math. Okay, so you can say import math as m. Now this math is a library. It's a library. A library means that it's a group of methods. I think we've done methods. If you don't understand what methods are, you just check in the previous video. You see what methods are. Now a library is a group of methods, more or less like a class of methods and functions, okay, that can do different things for you. Let me explain it very soon. Let's try it very soon. So I'm saying import math as m. I could just say import math, but I'm saying import it as m so that I will not have to be typing the whole long word math. I'll just be typing m so that it will see m as math. Do you understand? Okay, so let's see. All right, so I'm going to say bearing, because I'm going to deal with the trigonometrical signs. That's how come I'm importing maths, so that it will help me. So bearing equals to is tan inverse of change in eastings over change in northings, right? So bearing equals to m dot arctan. Tan inverse is arctan. Okay, I think you should, if you don't know this, then you can learn from here. Tan inverse is arctan. So change in eastings divided by change in northings. All right, now this would give us an angle. Okay, it will give us an angle. If you look at the laws here, you'd realize that it will give you an angle. Okay, so depending on where your coordinates, so that's why we've left this print statement to be there, so that it can tell you where your quadrant fell. Okay, it can tell you where your quadrant fell. Then you can decide whether it's an easting, whether it's in first quadrant, second quadrant, third quadrant, or fourth quadrant. Okay, so we come down here, we calculate our bearing. Bearing equals tan inverse of change in eastings by change in northings. Now we need to come and decide. Okay, so this is where you would find it a little complicated. We would be writing a lot of if statements. I believe you understand if statements by now. We've worked with it. We've solved a problem with it when we were doing the grading students by their marks. Okay, I think we worked with it there. We'll come to it again. So what the if statement is going to do is going to consider the change in northings and change in eastings. Okay, it's going to be checking. Okay, if the change in northings is positive and the change in eastings is positive, then do this. If the change in northings is negative and the change in eastings is positive, then do this. If both are negative, do this. If both are positive, do this. If the other is negative, you understand? You realize that I'm using F. So that's where the conditions come in. All right. So let's look at it. So I'm going to say if change in eastings. So let's work with the first. I think we should be working with our comments. Okay, so both are positive. So if change in eastings and change in, okay, is greater than 0. Okay, I mean, yeah, it's greater than 0, and change in northings is greater than 0. So this condition says that if they are both positive, anything that's greater than 0 is positive. So if they are both positive, then do this. We'll come back to it. I want us to define our conditions and make sure we've not missed anything before we come back and fill in our loops. Okay, now elif, I think I should leave in some spaces. Elif, change in This elif should be in line with the if statement. Okay, elif change in easting is greater than 0 and change in nothing is less than 0. Okay, change in nothing is less than 0. Then what should we do here? Let's for now print something here. I think let's just say if changing instincts is negative, I mean is positive, and changing nothings is negative, that will mean the second quadrant. So let's say instincts is negative, I mean positive, and nothing is negative. All right, I'll just copy this one and keep it in my clipboard because I know I will always need it. You know, the whole thing. Just copy the whole thing. It's a good time copy and paste exists. All right, then we come to another elif, another possibility. It's possible that changing instincts is rather negative. Okay, so it's rather less than 0, and changing nothings is instead positive, greater than 0. Then we will print here, and say changing instincts is negative and this guy is positive. All right, another condition, elif changing instinct. So the another condition could be that they are both negative. Okay, so they are both negative and changing nothings is also less than 0. And we print I think we could just print both are negative. Okay, so both are negative. All right, now with this, what if your answer is 0 0? So what if your change in nothings is 0 and change in instincts is 0? You realize that it's not going to fall amongst any of these ones. Okay, so let's if they are both 0 0, technically they are both positive and technically they are both negative. Okay, so we, in order to handle things like this, you put a default statement. Okay, else make sure it's in line with the condition, else print please check your values. Now honestly, if you are having changing instincts to be 0 and changing nothings to be 0, then it means it's the same point. You understand? So you can't really calculate the difference between the same thing. It's the same thing. It doesn't make sense to calculate the difference. Okay, so yeah, it means you are dealing with the same point. All right, so now that's how this else statement is important. It's a default thing. Okay, so that if any of them does not run, this else will definitely run. Okay, all right, so now that we have our conditions set, we would come here and take one. Okay, for now let's leave the print statement so that it will be guiding us as to which one has won and which one has not won. So for the first one, we will realize that okay, so we will realize that if they are both instincts, then it means that our bearing from this law, okay, from this rule, our bearings will be the same as the angle. Okay, all right, so our bearing will be the same as the angle. So our bearing equals to, so absolute value of bearing. okay, just in case it's negative. All right, so the first condition is done. Maybe when we are done, we can look at it again to be sure that it's working for almost every, to be sure it's working for every kind of value we put inside. So for the second one, if the change in eastings is positive and the change in northings is negative, it's falling in the down right corner, right? Down right corner. So in the down right corner here, the down right corner here, down right corner, this guy. It means, like I was explaining, our angle will be with respect to the y-axis. Okay, so if your angle is with respect to the y-axis, you can just that you take the absolute value of that angle and subtract it from 180, or you take the absolute value of that angle and then what was I saying? Yeah, you take the absolute value of that angle here, that's the angle here, and subtract it from 180 to get this whole value. Or if your angle is negative, you just add it to 180, it will still be the same thing. All right, let's see. So like here, oh, that's actually an angle, not bearing, sorry. So absolute value of the angle, not okay. So now our bearing will be equals to absolute value of the angle minus 180. I mean 180 minus absolute value of the angle. Okay, so I'm going to say 180 minus absolute value of the angle. Okay, in case the angle is negative, usually when you are having a negative eastings or negative northings, anytime one of them is negative, it means that the angle you get is likely to be negative. And if you are doing it manually, you can add 360 to it in order to get its positive value. No, we don't have negative angles. Okay, so you add 360 to it to get a positive value. So yeah, that's how it is. So now, yeah, so that's for the second statement. And then we would have gotten our bearing. Now for this for the third statement, okay, it says that eastings is negative and northings is positive, so it's falling in the upper right corner. This one, easting is negative, negative, positive, so it's falling here. That's this angle, I mean that's this scenario, and our angle will be here. Okay, so what we can say is 360 minus that angle will give us our bearing. Okay, so now let's see. Our bearing will be equals to 360 minus absolute value of our angle. Okay, absolute value of our angle. All right, and then for this one, our bearing, so this is when both are negative, our bearing will be equals to, so both are negative, let's just look at it. If both are negative, that's this case, and it's with respect to the y-axis, just add 180 to this angle. Okay, this is 90, 180, so 180 to this angle will give you the bearing from top to that place. Okay, so 180 plus that angle, 180, sorry, 180 plus absolute value. Now it's important, if you are not working with the absolute value, you never really notice when it gives you a negative answer. Okay, but when you're working with the absolute value, you realize like you are controlling, how do I say, you are eliminating a lot of errors. Okay, at least you know you're working with a positive value, so you don't have to think when it will give a negative answer or when it will give a positive answer. Okay, all right, so now when you get your bearings like this, then you can say print bearing. Okay, so let's try it again this time and see how it goes. Okay, so 642.515 483 483.980 548.005 594.279 359. So you're saying easting is negative and northing is positive. 359.29. Let's start it. Okay, and then with the distance, for the distance part, the distance, we are going to use this formula. Okay, let me use this formula. The distance is changing, the change in distance squared by the change in nothing squared, all square root. Okay, now we already have the change in distance, we have the change in nothing, so we just have to square them. Okay, so I'm going to say distance, right? Distance equals and m dot sqr. Now, sorry, this will give you the square root. Okay, square root, then in brackets. So inside this one, I'm going to put in brackets. In brackets here, the change distance star 2. Okay, that's our 2 or exponent 2 means square, and then plus another bracket, change nothing star 2. Okay, and that should give us the answer. So I want to bring this one down. Okay, and I'm going to say and distance, so yeah, and distance so I'll say space comma distance. I should put this guy here. So okay, so like this. So it's going to run it and then it will give us the distance. So let's see. So let's see. So I'm going to give it the values now. We are going to see if it works. 642.515.483.980. Then 548.005.594.279. Okay, so it gives us the bearings and decimal degrees and the bearings in DMS, and also gives us the distance. Okay, so you can always choose to round this up to the nearest whole number and add a unit to it if you know what units you are working with. So this one, for instance, you know you are working with it, so you can add units. Okay, so I'll see you guys in the next